we're going to look at a sample calculation that you might get if you did an EDTA experiment to determine the total hardness of a water sample. So the question, a sample of water was analysed in order to determine the total hardness of the water. 50 centimetres cubed of the water were placed in a conical flask and some buffer solution and areochrome black tea indicator were added. The solution was then titrated against 0.01 molar EDTA solution. The average titration figure was 15.2 centimetres cubed. Calculate the total amount of hardness in the water. Now, before we start this, we just need to quickly skip back over a couple of parts of that experiment. One thing that's important here is that your hardness is assumed to be all caused by calcium carbonate. So even though the hardness could, of course, have been caused by magnesium ions just as easily as calcium ions, we assume that all the hardness here, the total hardness here, is caused by calcium carbonate, and that's what's called a convention. It's just the way we do it. Now, one other thing, the unit for total amount of hardness, and this won't come into it until the end of the question, but the unit for total amount of hardness is parts per million of calcium carbonate, parts per million, and that is the same as milligrams per litre. Now, other than that, we're looking at a very straightforward V1M1N1 calculation. So let us look at our V1M1N1 equal to V2M2 over N2 calculation. So we'll start with the water, and the volume of the water was 50 centimetres cubed. 50 centimetres cubed. Of course, we're trying to work out what M1 is. And now we come to another little interesting bit of this calculation. The reaction ratio between your calcium ions and your EDTA is taken always to be 1:1. So we will fill in a 1 for our N1 there. And now we'll look at the V2M2 over N2. So the volume of the EDTA that we added was 15.2 centimetres cubed. 15.2, that was our average titer. The molarity here was a 0.01 molar EDTA solution, and as I said, the reaction ratio is 1:1. So when we solve all of that for our M1, we will find that the molarity of your water is 0.003 moles per litre. Now, as I said, we assume that that hardness in there is all caused by calcium carbonate, CaCO3. So that's 0.003 moles of calcium carbonate per litre. Now, we are looking for the total amount of hardness, and I've just told you that the unit we use is parts per million of calcium carbonate, which is the equivalent of milligrams per litre. We are currently in moles per litre. We take our standard method there of going from moles per litre to grams per litre, and we'll do that by working out what the RMM is of our calcium carbonate. And it's a really easy one to remember. It's 100. So if we've 0.003 moles per litre, and we multiply that by the RMM, multiply it by 100, that will give us 0.3 grams per litre of my calcium carbonate. Calcium carbonate. As mentioned above, it's not grams per litre we're looking for, it's milligrams per litre. And there are 1,000 milligrams in a gram. So what will I do with my 0.3 grams per litre? I will multiply it by 1,000 to get my milligrams per litre, and that will be 300 milligrams per litre of calcium carbonate, which gives me my answer then. So my total hardness in this particular calculation is 300 parts per million of calcium carbonate. And that's it for that particular calculation. That should help you to do questions 19.3 to 19.5 at the end of the chapter.